All righty. Hello, everyone, and welcome to the NowSecure Tech Talk for May. My name is Brendan Hahn, Senior Product Marketing Manager here at NowSecure, and I'll be your host for today. I'm joined by David, a Senior Pen Tester from NowSecure, to give a hands-on tutorial on exploiting WebViews using Frida. Just a few quick housekeeping items before we start. We will have Q&A at the end of the Tech Talk today, so please feel free to ask any questions you have with the QA Zoom feature. And we will also have chat enabled for today. So feel free to throw any questions or comments in the chat there. We host these Tech Talks monthly. So join us in June, where we will be joined by Andrew and Kevin from NowSecure, who will be discussing building mobile apps with the help of AI like GitHub Copilot. They'll jump into what GitHub Copilot can and can't do well, iOS and Android Copilot experiences, and suggestions on using GitHub Copilot today for mobile app development. With that, I'm going to hand it over to David to jump on into our topic for today.
All right. Hello, everyone. My name is David, and I'm a senior mobile application pen tester here at NowSecure. And we're just going to go ahead and jump right in to exploiting some web views. So I've created a little app, just very super simple app, and I brought it here in JADX. So you're gonna take the compiled APK binary and you're gonna toss it into JADX for some static code analysis. And it's a very basic app, but the very first thing that I did want to kind of mention is that in a lot of WebView exploits that I've seen just publicly, like on the web, some POC write-ups, it's basically dependent on the WebView activity that I've highlighted right here being exported equals true. But here we have exported equals false, which means that we're not going to be able to call this activity or manipulate this activity using like ADB intents or anything like that. So I'm going to show you an alternative way, because in most mobile applications these days, or at least ones that I've specifically seen, none of the WebView activities really are ever exported. They're all just exported equals false. So this is more kind of like a real world type of scenario. So if we go into the main activity here, we see a lot of stuff here. Not a lot of it makes sense, just because of the way JADX kind of decompiled everything. But if you notice up here or on the left-hand side, we do have a WebView activity. So we're going to go ahead and jump into the WebView activity, and we're just going to check it out. So here we see config WebView function, and it takes in a string, and that string is a URL. Normally, this will be obfuscated, or it won't have like a one-to-one for the naming conventions of what's in the actual code, but this is a debug APK, so all of the naming conventions should be spot on. So here we see how the WebView is configured. So we see that it's set up with a Chrome client, so it's using the Chrome WebView. We see that it supports some zoom, some display options and everything. It has a JavaScript interface, and it has JavaScript enabled set to true. So first thing, we're going to go through this in stages. The first thing that we want to do, since it takes in a string URL, and we see on this last line here, it loads that URL. Well, we want to manipulate that. We want to see if it's possible to redirect that that URL to something else. So if you give me one moment, I'm just going to share my mobile device. And this is the application. Not a lot going on here. There's a button in the middle of the screen that just says WebView, and when you click it, it should go to the NowSecure website. So we're going to go ahead and click it, and it goes to the NowSecure website. Great. So that is the official functionality of this application. So now if we go back, all right, so we want to take that URL of that web view and just direct it somewhere else. So the way that we do that is by using Frida, the magic of Frida. So we're going to go here, we're going to highlight this config WebView function, and Jadix makes it really easy for us to be able to create a Frida script in order to manipulate this WebView. So we're going to right click on the function, and we're just going to go down, copy as Frida snippet, and then we're going to go into an IDE, integrated development environment of your choice. I personally use VS Code, and we're going to go ahead and paste it in here. So I've already done that, but if you need to see it, so this highlighted portion right here is just what you get when you do copy as Frida script in Jadix itself. So what I did is I added a URL parameter in here to set it to google.com. So we see we have a function here. The function takes in a string URL. I'm setting the value of that URL. And then if all goes according to plan, we should be able to go to google.com instead of NowSecure.com. So we're going to go ahead, save this script, and we're now going to launch Frida in a command prompt. Let's see if I can find the right one. Yep, I did. So as you can see here, I had some previous stuff because I was testing it a little while ago. So we're just going to go ahead, and this is on my desktop where I have the TechTalk JavaScript file, which is this file right over here, which is going to, at runtime, inject google.com into that URL parameter when that WebView function is called. So we have here, we have the package name, and this is just a normal Frida one-liner. So we're going to go ahead and we're going to run it. Let's get the app up here. So we're going to hit enter, run it, and it's going to do its thing. Now, when you see this right here, that's how you know Frida is working. That's how you know it's going to do something. So when we click this WebView button, not only will it go to Google instead of NowSecure, but it'll actually tell you, it'll actually have like a little bit of a logging comment right here. And that's a really good way to try to debug WebViews if it doesn't redirect, to see what's happening there. So we're going to go ahead and click the WebView button. Hey, and it goes to google.com instead of NowSecure. And right here, we have this little logging event that the URL is called to google.com. And that is exactly what's happening here. So that doesn't really seem too impactful at first glance. So you're like, all right, well, locally, I redirected this WebView, not a big deal. It's not widespread. I can't do it server side. I'm really only hacking myself. Like, what's the big deal? Why would you ever do this? Well, continuing onward, if you can redirect the URL, let's go back to the settings. So the next step to escalate the attack is to see what type of settings the WebView has. So now here we see the set JavaScript enabled is equal to true. Well, that's very interesting. So that theoretically means that if I can somehow get a JavaScript script or HTML, right, into that WebView, then it should execute that code. That's exactly what that means. And this is an extremely common setting because a lot of mobile applications use JavaScript for their UI or to point to various other resources that is shared with their web application. So you might be thinking, well, I don't have an attack server. I don't have anything super crazy or fancy. Well, you don't need anything crazy or fancy. You just need a very fun tool. I'm currently working on a Mac. So for me, Apache Web Server is just automatically like on my computer. So you're going to want to go ahead and start your Apache Web Server. You could also do that in Kali Linux. Really, any web server will be fine. And then once you have it running, just go to your local host in a web browser. You should get the "it works" message. And then, okay, great, that's local. Everything's local at this point. Well, can I put localhost? Can I inject my local host into the script that we have? and kind of toss it some malicious scripts to see, how the application handles it? Well, probably not, because it's on your local host. You want something a little bit more robust. You want something ideally on the public internet that has HTTPS, because some applications will kind of block all HTTP traffic. So you want HTTPS. So the way to do that is by a really awesome tool called ngrok. So if you download the ngrok tool and you have your Apache web server running, what this does, I already have it running here. What this does is that it proxies your local host on port 80 to a public ngrok-like domain. So not only is it HTTPS, but it's a public domain that you can call from anywhere. So you're not going to hit any like brick walls. You're not going to hit really too much resistance trying to inject a malicious script into the web application. So fine. So the way that we make sure that ngrok is running is the exact same way that we do it for the Apache web server. Is we just go into a web browser, paste it in, and we get that it works message. Now, in order for you to have access to any malicious scripts that you might have on like your desktop or anything like that, you need to, for Mac specifically, you need to put them in your documents folder. So documents folder, just one second. Does require a certain level of permissions. And the way that you could find it on Mac is just library, web server, documents, and then anything in this documents folder you can call from your Apache web server. But now, since your Apache web server is proxied to the public ngrok domain, you can actually call anything from your documents folder in that ngrok domain. So what we want to do here is we want to just do a simple test. So we have the simple cross-site scripting, or XSS.html. So we have just a very simple script here. It's just script alert and then a message XSS. And this is just the normal simple script that pretty much everyone uses to test cross-site scripting. But in our case, we are kind of testing cross-site scripting as well, but we're also testing the JavaScript functionality to make sure that it can that it executes just arbitrary JavaScript within the web view itself. So the way that we call this is we just have our ngrok URL right here. We do a / and we just enter in the script name. And then once I hit enter, we should get a pop-up message in our browser that says XSS. And we do. So, and we got this pop-up message. So the script is working. It's working as expected. So now what we'll do is we'll copy this and we'll go back to our Frida script and we'll replace google.com with our malicious payload. Don't forget to save it. And then we're going to rerun Frida with the exact same command. And what should happen is it should redirect the web view to our malicious payload. And we should see that pop-up happen that says XSS. And that is how we will know that the web app or the web view is executing this arbitrary JavaScript, but we already kind of know it does since the setting is set to true. So we'll just go ahead and share our device, which is set to Google, which is fine. So we'll just exit out of that, run the Frida scripts, and we'll go ahead and click this guy. Bam, right? We get a pop-up alert that says XSS, the exact same behavior that we saw in the web browser. So we know that this web view will execute arbitrary JavaScript whenever it's sent to it, right? You can also test this if you have some other just random HTML going on. But that's a little bit different since you'd be testing the HTML and not necessarily the execution of JavaScript. But unlike web browsers, that cross-site scripting is a pretty big problem because you could steal cookies and like session cookies session IDs, all that good stuff. On a mobile application, using WebViews or browsers, it's not so straightforward with cross-site scripting. So in a mobile application, all the cookies are stored in like a local file directory, which has various permissions on it. So we can't really grab anything right now unless we can find an alternative route. So we've exploited the redirect, we've exploited cross-site scripting or the execution of arbitrary JavaScript, which is also kind of known as like HTML injection. So now if we go back to the WebView setting, we see that there is a JavaScript interface, which is very interesting. So if there is a JavaScript interface that is configured with a WebView, and you have control over that WebView, and that WebView also has JavaScript enabled, you can gain access to the JavaScript interface that is configured with the WebView, and you can actually gain access to the code and the functions of that interface, and you can execute them from the WebView directly. So I know that's a pretty big mouthful, but let's kind of see it in action. So we're going to go ahead and check out this WebView interface right here. So this is just a normal, just intro level, implementation of a JavaScript interface. We have like our little code word right here, which is just Android in quotes. So if we go in here and look at the actual WebView interface, anything in this WebView interface that has this @JavaScript interface, we can call and execute that function within our WebView. So here I gamified this, this demo a little bit. So here we have the display flag function, which will return our super secret code, which our super secret code is just a random number between 1000 and 2000. Nothing too crazy, but this is kind of just supposed to demonstrate maybe something worse. Maybe you have some like API secret token generation that someone could gain access to. Really anything you can think about. Internal code execution is kind of what we're talking about here, which is very interesting. So how do we do it, right? That's the big question. So if we go back to our scripts, we go back to our IDE right here, we have the flag.html, and I'll kind of explain a little bit of this. So we're going to do a document. So we're going to have two, first off, we're going to have two script tags, right? Because we're talking about JavaScript right here. So we're going to execute some JavaScript. That's going to do a document.write, which will write whatever is here, within the parameters onto the page. And we have Android.displayFlag. So basically, everything lines up. So we have our little keyword right here, which is Android, which is exactly why you see the Android here in our HTML file. And then .displayFlag, open close parentheses, is the function of the web interface right here. So when we run this script from our attack server, it's going to display the super secret code on the screen within the web view. So we can go ahead and do that. All right, so this is flag.html. So again, what we'll do is we'll open up our browser just to make sure everything's working correctly. Well, it's not going to do it here because it doesn't have an Android. So we won't be able to do that, but we will be able to copy paste it into our URL, flag.html. And then again, we're going to run the exact same Frida command. And then it should call the internal function and then display the contents of that onto the screen. So let's grab the mobile app and let's just simply reset it. Run Frida. Now, when I click this, we should see super secret code and a random number between 1000 and 2000. So we're going to go ahead and click it. And that's exactly what we see, super secret code 1324. So this effectively called that internal function and executed it on my terms within the web view for me to get the, super confidential information. This type of attack method can be used in a multitude of different ways. A lot of them, if you can pull some internal code execution of some sensitive information, that's definitely kind of like a high finding or a critical finding or something that should be looked at immediately. Also, I've seen there is a like a function within Android Studio for WebViews specifically. It's like a get file from URL or something like that. It's been deprecated since Android API 30, but I have seen it out in the wild in applications, and that can be utilized to get those session cookies, because what you can do with it is the exact same thing that we did here, except instead of calling an attack server, you call the internal file structure, and then you display all that internal files. Even if it has admin privileges or whatever, it'll display everything on the screen, so you can kind of cherry pick the type of information that you want to get. So so that is pretty much it. I know we kind of went fast, but a good thing to note is that we do have a blog version that goes step by step with a lot more explanation than I gave here. That comes out on the NowSecure blog page next week on Wednesday. So if you enjoyed the presentation, I strongly urge everyone to give it a try themselves. I do have the source code for this application, as well as a compiled APK. There's a link to it in the blog, to a public GitHub repo that you can just download the source code and compile it yourself. And you can try to exploit it or do some other cool stuff. But yeah, that's pretty much it. So we'll go ahead and take any questions if anyone has any.
Awesome. David, thanks so much for the demo. That was super interesting, and it's always great to see the Frida magic at work. We do have a couple of questions here. So one came in through our Q&A box. Reminder, if you have more questions, feel free to throw them in there. We did move pretty quickly through that demo, which was spectacular. But the first question that we got is from Esteban, and the question is, how can this be exploitable by an attacker? Would you need the victim device to be with Frida installed? So David, I think you can jump in and take that one.
Yeah, that's a good question. We didn't really hit too much on that. So yeah, so this is a local attack vector, meaning you do need to have the physical device, a jailbroken device. You do need to have Frida on the device in order to exploit this kind of thing. However, you wouldn't really be attacking it to kind of like hack an individual. You would be doing it to prove the insecurity of the mobile application itself and prove, hey, you thought that all of these files were protected, that all of this sensitive data is protected. Well, I have it, and I can have it on my screen. So that can include maybe less of the session tokens and more of like any like secret API tokens, any initialization vectors, any crypto findings in there, any information that you can use to possibly decrypt anything of higher value. You just kind of want to see how the application is set up and just see how high you can escalate it. Because in some cases, you can escalate it really, really high. And in other cases, you just kind of stop at the URL redirection. So it kind of depends, but this is more so an attack you do on the application itself and not necessarily towards like an individual, if that makes sense.
Definitely. Awesome. So there is one other question that I can take really quickly before we jump into another one for you, David. This person asked, where can I watch the video? I joined late. So a recording of this session will be provided to everyone who attended today. It also gets uploaded to NowSecure Academy, which you can navigate to by going to academy.nowsecure.com. Totally free resource to you. We have a whole bunch of resources in there. It's like 60 plus hours, plus from some certification courses, both for developers and security professionals. So feel free to set up an Academy account, take some courses, but this will also be live in there. Okay, so David, a couple of other questions for you. The first one is, how can we protect this URL from attacks?
Yeah, that's a good question, and one that I was very prepared on someone having. So basically, I'm not going to go too in depth with it because it will take a more than just 30 seconds to explain. I will be doing either an additional tech talk or releasing an additional blog as like a part 2 to this one on the defending perspective of it. So look out for that. But essentially what you would want to do for the URL to kind of mitigate everything, you don't want to use JavaScript enabled equals true unless you absolutely 100% have to. And then you can put some kind of safeguards in place for the URL redirection, meaning you could do like, you could have like some like regex, or you can have like an allow list of domains that you check for like on the client side. Since you're probably already doing that on the server side, you just kind of implement it in the code. But the interesting thing is, depending where you set the check, if you set it too early in like the whole WebView configuration chain, then someone could just call the function that comes after it, that after the checks, and just completely bypass it. But you definitely want to have like an accept and like deny like list somewhere in your code to make sure that you're checking that when you go use the WebView, that you're winding up at the correct URL and not just something that's edited. But that, again, that is kind of super technical, but I will be having an additional blog and or tech talk to go into a deep dive with code examples, much like I did this time, with how to do the defending on that side.
Awesome. Thank you. We've posted in chat here as well the subscription landing page for our blog. So if you want to read more when that blog drops next week from David, then you can subscribe there. We have some more technical questions in chat for you, David. So could this be used to enhance a directory traversal attack?
Yeah, 100%. So what I was kind of saying a little bit earlier, there is a WebView setting. It is called, sorry, it's very tiny on my screen. It's called set allowed universal access from file URLs. If you use that in a configuration of a WebView and that is set to true, you essentially can do a full-blown directory traversal attack into the entire file contents, regardless of permissions. And you can display all the contents of those files within the WebView itself. It's really cool. I've seen it in a few demos here and there, but a good point to make is that method, or that function, has been deprecated as early as API or Android API 30, but you can still, like, Android Studio still allows you to use it. So you definitely still do see it in the wild. So yeah, you can 100% use it either just full blown as a directory traversal attack itself, or you can use to enhance it and then just display that stuff on screen, since it does execute arbitrary JavaScript.
Got it. We have a follow-up from Esteban that says, can't this vector be viewed using JADX and reversing the APK?
Yeah, and that's exactly what we did. I put the APK file into JADX. and I examined the WebView configuration. So it might have been a little misleading because JADX does have like a dark mode and dark theme. So many of you might have thought that I was just looking at the IDE itself, but it wasn't. So everything that we viewed in here was using JADX whenever we were looking at the code. So yeah, that is exactly what we did.
Awesome. So we have another question here. Does another application installed on the mobile device can hijack the request URL by WebView in the original application and redirect to a different server for phishing, etc.? So
that's awesome. That's a really awesome question. So I have seen this type of WebView exploitation work with a malicious application installed onto the device, but it only worked because the WebView activity was exported. And that's exactly what you look for in the Android manifest. If it's exported, meaning exported equals true, then you can call it from another app. But if it's exported equals false, you can't. So you might be able to engineer a very interesting way to maybe use Frida within an app to inject it. But from what we just went over, if it's not exported, you can't interact with it with another app. So you would have to use Frida. I'm not a super expert on Frida and implementing it within a malicious app to then attack another app. So it might be theoretically possible, but it might not work out as simple as that.
gotcha. Cool. And then we have one last question here that said, could you exploit it using a portable Frida injector, basically an app that can execute Frida scripts remotely if that injector app also ships a root exploit with it? That sounds similar to the last question.
Yeah. So if you have an app that does everything that Frida does and can hook into another app at runtime and inject and chain, and like if you can run Frida scripts within another app, then yeah, you can do it. It doesn't matter if you do it from your laptop or you can do it from an application. It should all generally work the same because all you're doing, it's a very simple Frida script. You're just changing the URL parameter within the function. So if you can inject it on your computer, and if it's possible to inject it using a mobile application, then you should be able to do it all the same.
Awesome. Well, that wraps up for Q&A. I recognize that we're a couple of minutes over here. David, I really, really appreciate you coming and joining us today and doing this demo. This was really fun. And I'm really excited to read some more details in our blog. Be sure to join us next month for our tech talk around building mobile apps with the help of AI tools like GitHub Copilot and others. We'll be getting into kind of best practices around that, suggestions, experiences that the team has had. So yeah, with that, thanks everyone for joining and enjoy the rest of your day. Thanks all.